Welcome to a demo of Radar X, an interactive interface pairing contrastive explanations and revised plan suggestions. Radar X extends Radar, which is a proactive decision support system powered with automated planning techniques to aid the human in the loop in complex decision-making scenarios. In Radar X, we consider a firefighting scenario where a fire chief, along with several other authorities, has to come up with a plan in response to a fire. Let us assume that the goal here is to extinguish a small fire. For this goal, Radar X comes up with this plan. Now let us say that this plan does not meet the user's expectations and the user would want to know why the system came up with this particular plan as opposed to some alternative plan, which is referred to as a foil. Notice that the foil can be a partial plan that represents the user's set of expected plans. To add the foil, we click on the Add Foil button that redirects us to a new page where actions can be added. Radar X uses off-the-shelf speech-to-text services to allow naturally specified foils. For example, if we want to replace Contact Media Fire Chief, which is present in the suggested plan, with another action, Contact Media Transport Chief, we can do this by asking a natural contrastive question. We can use the start and stop buttons to record the question. Why Contact Media Fire Chief instead of Contact Media Transport Chief? The action transcript panel displays the foil action for confirmation and then replaces the action that is present in the current plan with this action. The confirmation in the action transcript panel is done to ensure that the inaccuracies in the existing speech recognition technologies do not add unidentifiable actions into the foil. You can also add actions by simply selecting from the drop-down list and clicking the Add button. In the suggested plan, as shown in the current plan panel, two specific parts are incongruous with the user's expectation. First, the user wants to send out information via a social media post using Send Social Media action alongside addressing the media themselves using Address Media Fire Chief action. But they are not aware that once posted on social media, the media will pick up the news from these forums and the fire chief need not separately address them. Hence, both of these actions are not possible together. Second, the user expects that big engines should be deployed along with small engines. That is, the actions deploy small engines and deploy big engines should both be present in the plan. Here, the user is unaware that both types of engines cannot be deployed together and hence both the actions cannot be present in the plan. Therefore, when Radar X presents the plan suggestion, the user does not expect that only one of each of the expected action pairs, that is Address Media Fire Chief and Deploy Small Engines, appears in the suggested plan. Hence, the user raises this foil. One can also see Send Social Media and Deploy Big Engines as a latent preference of the user that are not specified explicitly. Radar X enables the user to ask for contrastive explanations by specifying foils. We look at scenarios where the mismatch between the suggested plan and the expected plan arises due to a model mismatch. We consider the case when the specified foil cannot be part of a valid plan in the planner's model, and we adapt existing work on model reconciliation explanations to come up with contrastive explanations in such settings. Note that we assume to have the human's model of the task along with the planner's model while coming up with explanations. Explanations can be generated by clicking on the Foil Explanations button. The objective of Radar X here is to find a particular model starting from the human's model of the task where the specified foil cannot result in a valid plan. Essentially, we want to find the minimal number of model updates that need to be made in the human's model to get a new model where the foil is invalid. The differences between the initial human's model and the found model are presented as the explanation. Here, the minimal explanation is that the action Send Social Media has a delete effect, no social media, and that's why the foil is invalid. The human can then update his or her model by just clicking on Update Models, or if the human truly believes that the planner is at fault or the planner's model is at fault, they can select the checkbox and reject the model update, thereby changing the planner's model. Now, even though the user understands why the specified foil is invalid, the foil can also be indicative of the latent preferences of the user that were not specified explicitly. Now, using the specified foil, we refine plan suggestions through 3 different interaction strategies. Let us now look at these approaches. In this approach, we try to find the closest plan to the foil, which implies using the largest part of the foil in the revised plan. To achieve this, we revisit the plan recognition as planning methodology to come up with a novel encoding that compiles the specified foil into soft constraints with penalties for violating the constraints. Once the plan is generated, the actions of the foil used in the plan are encoded in a different color. Also, as you can see, the current plan panel is replaced with the specified foil panel, which encodes used actions in green color and unused actions in red color. The user can just click on these actions directly to add or delete them into the foil. If the user is satisfied with the plan, they can accept the plan or engage in recurring interactions to reach to a plan that is of the user's liking. Even though this approach provides the closest plan, if all the actions in the foil are not equally important to the user, there is a chance that the planner uses the less important actions in the foil, discarding the important ones. If you recall, the latent preferences of the user that we mentioned in the example, which were the actions send social media and deploy big engines, were actually not used in this revised plan. This would probably not satisfy the user as the planner discarded the more important ones and used the less important actions. Now, to avoid such situations, we present a different approach called the conflict sets approach. In this approach, we aim to present the subsets of the foil that contain conflicting actions, which means that all the actions in the subset cannot be used and the user has to sacrifice one of the actions to resolve the conflict. Such sets are presented to the user and the preference elicited is used to generate the plan. Note that some of the conflict sets presented to the user may not be resolvable in the humans model without additional explanations. As a next step, we look to allow for providing such explanations. As we can see here, this is the first conflict set that is presented. Now, both these actions cannot be present, hence we have to remove one action from this set. Let us select deploy small engines. Let us remove it. Now, the other conflict set is send social media and address media fire chief. Let us sacrifice address media fire chief. Now, RadarX should come up with a plan that uses send social media and deploy big engines because those were the preferences that we elicited. There we go. Now, the user can either accept this plan by clicking on the accept plan button or engage in further dialogue with the system. This computation of conflict sets is expensive as the search is in the space of subsets, which can blow up exponentially. Now, maybe instead of presenting the conflict sets to the user, we can also look to present all the maximal valid subsets at once as options to choose from. Now, that is our next approach, which is called as the plausible sets approach. In this approach, we present all the maximal valid subsets to the user, and the user selection is taken as the preference to generate the preferred plan. A maximal valid subset of the foil is a set where all the actions in the set can be used in the revised plan. Now, there is a possibility that there are more than one such sets within the foil. Hence, all such valid subsets are presented to the user at once. Here, as you can see, because of the conflict sets that are present within the foil, which were presented to the user in the previous approach, the planner can only use any 2 of the 4 actions that are present in the foil. Now, all the combinations have been presented to the user because all of them are plausible, and we will have to select one of these options. Let us select address media fire chief and deploy big engines. Now, as you can see, the suggested plan contains our preferences. In this way, RadarX builds the trust that the user has in the system by letting him or her drive the explanatory dialogue and provide foil-based explanations. On top of that, it uses the specified foil to give revised plan suggestions and satisfy the user to the maximum extent possible. Thank you for watching this demo.